Now we are in a position to state Gauss law. The flux of the electric field through a closed surface, which is integration of E vector dot dA vector over the entire closed surface. This is given by charge enclosed by epsilon naught. This is what is Gauss law. The most important thing about Gauss law is symmetry. In every situation we discuss, in every problem we solve, we will try to use symmetry. So that is the most important thing about this law. Now, suppose we have a point charge here, Q. We want to find the electric field at a distance r. So we'll draw a spherical Gaussian surface enclosing this charge. And now we'll look at the symmetry, that we call it symmetry arguments. It is very easy to understand. This is our Gaussian surface, also called known as Gauss surface. Everywhere on the Gaussian surface, a 3D surface spherical, okay, not circular, it's 3D spherical. At every point on the Gaussian surface, electric field will be radially outwards. Okay, this Q is positive. So electric field will be radially outwards. At every point on the Gaussian surface, the area vector, dA vector, also will be radially outward because the surface is spherical. So at every point, E vector and dA vector are parallel. That is the first symmetry argument. At every point on the Gaussian surface, okay, E vector and dA vector are parallel. That is the first thing. The second thing is that all these points on the Gaussian surface are at the same distance from charge Q. So the magnitude of electric field at every point on the Gaussian surface has to be same. So mod of E is same at every point on the Gaussian surface. Okay, this is the arguments. So therefore, this integration of E vector dot dA vector becomes integration of E dA, because theta is 0 degrees, okay, cos 0 is 1. So that dot product simply gives us E dA, because theta is 0 degrees. E vector and dA vector are parallel. And this E is a constant. So E comes out of the integration. And we get integration of dA over the closed surface. And that is simply E into A. So this is how things simplify when we use Gauss law. E vector and dA vector are parallel at every point. Magnitude of E vector is same everywhere. Therefore, this integration E vector dot dA vector over the closed surface simplifies to E into A. And Gauss law tells us this is Q enclosed by epsilon naught. Only one charge is inside, that is Q. And therefore E becomes 1 by A, Q by epsilon naught. Since the surface is spherical, area is 4 pi r square. So 1 by 4 pi r square q by epsilon naught. And that is same what we have derived from Coulomb's law, 1 by 4 pi epsilon naught q by r square. Therefore, Gauss law can be derived from Coulomb's law, and Coulomb's law can be derived from Gauss law. But Gauss law uses symmetry, and that makes life simple.